Okay, so this is Creative Rust. I'm super glad to be here. Thank you very much. Just really quickly about me, because I actually do have a lot of talking to do. But I want to get this out of the way. I'm Lisa, or Liz. If you want to search for me online, this is probably the name you want to search for. And I'm a creative technologist based in Berlin. What does creative technologist mean? That's a very good question. I'm still struggling with a good definition. But I like to think of it as finding solutions to more creative problems, and not maybe your everyday, day-to-day kind of technical problems. But let's see how that goes in the future. I'm still pretty new to it. And obviously, I like Rust. And these things together combined are more than enough reason for me to talk about creative coding in Rust. Since this is a Rust meetup, I don't think I have to do any language evangelism. And instead, I can focus on creative coding, which might be something that not a lot of people or everybody is familiar with. And it's also a very a broad field. There's a lot of things that go into it. So I want to take a couple of minutes in the beginning to kind of look at the different parts that make up the world of creative coding, because I think it's super exciting, or at least it's very exciting to me. Let's start with a quote or a definition, because it's always a good place to start. So Wikipedia says that creative coding is basically about creating something that is expressive instead of something that is functional. And I really, really, really like this, because it liberates us from this idea of that we have to code something that runs and that works, and that it has this single purpose, and if the code doesn't run, it's useless. And creative coding says whatever, as long as as long as it expresses an experience or a feeling or anything you want to express, you have creative coded. And I think this is already okay, we're free to do whatever we want. And this is, I can already feel I can breathe more freely after knowing this. So there are no mistakes. Perfect. Aside from this more headspace that I really like about creative coding, there's obviously a lot of very fascinating and cool technology that we get to play with if we want to dig deeper into creative coding. And I had a hard time in the beginning as well, wrapping my head around, okay, what are all the parts that make up creative coding, and what is all the things that is interesting and that is interesting for me specifically. And the list that you see is compiled from a little diagram that I came across when I watched a webinar by Luis Ferreira. And I thought this is really cool because it kind of maps out the different areas quite nicely. And I want to give you a little whirlwind tour of the things here on the list. Because if you deal with creative coding, you can work with artificial intelligence, especially things like generative adversarial networks, or GANs, are things that constantly blow my mind. These more anatomical, nature-inspired things that Sofia Crespo generates. There's this entire realm of physical computing where you get to play with sensors and motors, so take in input from the environment and then act out on the environment, or things like pen plotters, or anything that makes it makes its way from the digital back into the physical realm. It's super cool. It's super exciting. Electronics is a big part of what I spend a lot of my free time on. But there's also other cool stuff in the more audiovisual, actual performing in front of people thing. As an example, I picked live coding or algorave, where you can code music, you can have actual musicians perform with you on stage, and it's really so much to do and so much to see, all the way up to light art. I picked as an example projection mapping, where you can write visuals and code project imagery onto buildings or facades and make it match the actual architecture. You can have this animated or also interactive, and it's really it's so cool when you stand in front of it and you know that people made this and interact digitally with things that exist in the real world. Okay, I just throw a lot of things onto you, so just so you have at least one image in your head for all of these points. But the main part that I want to dig a little bit deeper here is the generative art stuff. It's also, I think, the easiest to get started with, because you don't need a lot of equipment or anything else. You don't need the hardware. You don't need buildings to project things onto. What you need is your computer. Perfect. So generative art. So we, from all of creative coding, we're now in like generative art, and there's also like a lot of stuff, or like a lot of areas within generative art that you can look at. Like it's really just like it can be data driven, it can be real time. There's lots of things that are happening. But it's like again a little definition maybe to work with, like what does generative art even mean? When we talk about generative art, we talk about art that is created by a system where the system has some level of autonomy, or like the artist does not intervene directly in a way with the art that is being produced. Because the artist in like the world of like generative art is the person that designs the system or lays down the rules by which the system then generates the art. So we have this kind of like rule system, and then like this based on these rules, art is created, and we define the rules. So this is really cool. Let's look at some examples, because generative art is not just computer visual art, the way that we will do it later, but it has or is applied in lots of different fields. For example, architecture. Here's an example where from like a grotesque style inspired not installation, but like it is 3D printed and then glued together and like fills entire rooms, and it's all like it was generated by a computer and then pieced together by the humans. There's obviously literature and poetry. Here I have an example from a French collective that already generated poetry back in the 60s, and the way that they wrote 10 sonnets, but like cut out the individual lines of the sonnet and put it in a book. And when you opened the book, the individual lines in the poem would like just like open in a random way once you open the book, and what you get is a randomly generated sonnet. And since they had like 10 sonnets, and it just like varied, like it was completely random at which they in which order these lines would fall. So they basically already generated poetry in the 60s without computer, purely like analog. And I think this is really cool, because we still are within the realm of this where the artist just gives you the rules, and then the system follows the rules and generates the art for you. We also have like generative art in music. Maybe most famously Brian Eno and the music for airports, which is like this very ambient, slow sound. But again, he just set like the stage of like, here's the rules by which the system then determines which note is played next, and this could actually be played until like forever and ever in infinity. And this was like already in the 70s, which I also think is like cool. There's so much history there already. And then like a more recent example of like more like the visual art stuff that you probably like, or like maybe see on social media or something. Here I picked some like imageries from an artist called Monoloid, who posts like on Instagram and Twitter, I think. And this is just a screenshot of his Behance page. Some like really cool stuff. You can see like how he's like trying to imitate brush strokes and stuff, and it's so fascinating, and it's really, really cool. And I thought it's like, this is like more into the direction that I want to get, even though we will not get as fancy. Sorry, time limits and stuff. But I like chose these examples to be a little bit all over the place on purpose, because they have this. I want to get this feeling across that we can definitely like learn from what came before us, because we have so. Maybe one step back, if we free ourselves from this like idea that we write code that has to solve a specific problem and it has to be functional, we have to like think of like, okay, it has to work now, and this is like what the thing that we code for. But in a more creative and expressive environment, we can maybe say, hey, the output or the feeling and the sentiment and what we created is more important than the tech that we used for it, or that we don't have to ensure that it keeps running forever, as long as like it ran maybe once and it created something, or it never ran, because maybe we do an art installation about error messages, and then the point is that it never ran, or something along those lines. And I like the other part is that I think it's so cool. So like why I also picked some stuff from like the 70s or the 60s is that I feel like there's more history to what we do than usually in tech. Usually it's like, oh, this framework is already 3 years old. Wow, it's so mature. But like with art, we have this we have this context of like, culture in a way already, that we can say it's like, okay, people have done this like 50 years ago, and I really enjoy this way of thinking of like, not everything we do is new. It's always been done before, but we can still learn and be inspired by the people who came before us. With that being said, I want to talk about a person that really inspired me in the last couple of weeks, which is who is Vera Molnar, and she gets the super cool title on Wikipedia. Pioneer of computer art, which is like, yes, if you get that title, I'm like, wow, you've done it. And she is really cool. She was born in 1924. And she's still alive, and she's still working at like almost 100 years of age, which is mind-blowing. Like, definitely life goals to achieve there. And she was born in Hungary, where she studied like art and art history. So she's like an actual like classically trained artist. But then in the 50s and 60s, she moved to Paris, where she thought of this the system by which she started to create art, which she called méthode imaginaire, which is basically exactly generative art. So she thought of like a rule system, for example, a certain grid and certain colors, and then certain rules by which these were like applied, and then created art based on the rules that she first thought of. So like basically generative art, except she didn't have a computer. But then once in the 60s, late 60s, computers were kind of more available-ish, at least to some people. The first thing that she did was make art with it. Really, really cool, like a real like pioneer. And what is also cool, I think, is not only that she started making art, but the way she brought the art, or like the computer-generated stuff, back into the real world is through the use of pen plotters. So you get like actual pens drawing the generated art. And you get this kind of like, yes, a computer thought of these forms, but you get this like actual ink on paper kind of real world, physical, tangible experience, which is really, really cool. And she's already like in this like, if you remember the creative coding techniques in the beginning, she's already like combining like the physical computing part, which is pen plotters, with like her generative art already crossing through all the sections that we get. So this is already super exciting. I'm really, really, really so in love with her and the work that she did. Let's look at some examples. So one of her earlier works here is Interruptions, which she already did in the late 60s. And I think it's just super timeless. This is like something that is just so cool. Like it's really simple, and it could still be something that people would generate today, or think of like, okay, how can I write a system that generates this kind of output? Very cool. Another famous one of her works is called Disorder. Sorry, like French native speakers. Which is like a series of like where she really looks into like this random rectangles on grids kind of thing. This is also like a very famous example that you see often if you look into tutorials on creative coding, or like where to get started, is like this idea of figuring out what people did who have done this like decades ago. So Disorder is a pretty good one. And then like from the 80s, there's another like pen plotter print here. It's called like from a series called Structure de Quadrilatère, or Square Structures. And when I saw this, I was really like, this is kind of like really cool. Like this one really spoke to me on some level. I'm not really sure why, but I decided that this should be the piece that maybe we can look at together and see how we can implement something like that in Rust. So now that I like threw a bunch of words and pictures and like a whole lot of input into your all's faces, let's talk a little bit about Rust and creative coding in Rust. I want to use a tool, or like a framework that is called nannou. It's probably the most mature creative coding framework written in Rust right now, at least that I'm aware of. And it's really cool because it's it's fairly young, but it like learned a lot from like the other creative coding frameworks out there, like processing or open frameworks, but also making some decisions that are very like future oriented in a way. So I'm like very excited about like all the features that are still to come. But it's already like in a super usable place right now, which is why we're going to use it. So the plan is taking this piece, square structures by Vera Molnar, and trying to implement something or like recode it in nannou. So we should make a plan. Okay, so let's assume that we're new to nannou and we don't really know what we're up for. So the first thing I would look is like what we have. Nannou has a template that we can use. We can check it out, get a little bit familiar with the idea and the structure and everything. Then obviously we have to find out or figure out how we can draw a random rectangle. Because this is, if we look at the thing, we have like, if we look at the original image, we have a rectangle that is made up of a grid of various random rectangles in different colors. So first we figure out how to draw one rectangle. Then we need to figure out how to draw a grid of random rectangles. I would choose picking colors next, but that's just my preference. This step could probably also go at the beginning or at the very end. And then I would say, so assuming that first we start with just a grid of a rectangle each, then assign the colors, and then per position in this grid, I want to draw multiple iterations or like multiple versions of or like just multiple rectangles in the same position on top of each other. And then I actually want to add some interactions because I really like playing with the stuff, like not just like generated once. The way you would do it and then print it or plot it out. But we have like, since we're staying digital for now, have the opportunity to play with things, just like play with the parameters and like have a little bit of fun with it, because that's the point, having fun and learning stuff. Okay, with that being said, let's draw some squares. And I have a slide intentionally left blank, so I have time to switch over to other stuff here. Okay. So these examples that I'm going to show you, they're already online on GitHub in the repository that together there's the slides that I showed you, or they're already online. And these examples with each step that I'm going through in a separate file, so you can like with comments, and there's also README. So if you want to like, if this is all very fast, and I realize it's very fast, you can like read through everything at your own pace later on, and hopefully it all works for you. It's not rocket science, I assure you. Okay, with that being said, the first step is looking at what we have. So the code that you see here is the example app template. So in the nannou repository, there is a folder called examples, and there's another folder inside that's called templates, where you find the app template. And this is the entire app template. And this is a fully functional nannou app. If we run this now, let's see. So this is called step 1 in the repository. If we run this, we get, this is the standard template, or the standard app template. It's just a window that draws a circle in the center of the screen. Nothing too exciting at first, but it's already pretty cool that with like really very little code, we already get this kind of output. So let's see how this works exactly. We get the nannou prelude. In the main function, we just like kick off this app. We don't actually have to look at this anymore. Just like this is where things go together and then start up. The most important, or like the things that are like interesting to us are a struct that is called model, a function that is called model, a function called update, and a function called view. If you hear the words like model and view, probably the association that you first have is like model view controller, and if that's the case, you're right on the spot, or like just right, because this is kind of like the overall architecture that nannou was built with. So like model view controller, where model holds your state, and view is kind of like just the visual representation of your state, but we don't really have a controller. We have more of this like the logic of like updating the state as you go, and then having the state represented. If you've maybe like played with things like processing before, or maybe like other game engines even, you might wonder, because like Vue is, like for me it was like a little bit unusual. The Vue is usually called something like draw, just like making clear that this is where like the drawing happens on the screen. But it's also like, it makes a lot of sense if you think of it from this like model view controller perspective. The other part is that the function that is usually called setup or sometimes load. So the first, like all the code that runs once in the beginning to set everything up is actually called model in nannou. This is where the window is created, and the model, like as our container for our state, is initialized, or like is instantiated, I guess. With that being said, this is what we have. We have the model struct that defines our upstate. The model function creates the window, initializes the model. Update would be a function that continuously runs to like update the model, and view is a function that continuously runs to draw to our screen. Cool. So this is what we start with. And let's see. So this is step one. Step one is just like looking at stuff. Let's see how step two works. So step two goes from drawing a circle to drawing a random rectangle. This one's pretty ugly, but this is what you get when you draw random stuff. Let's run it again. More like it. So this is one way to draw a rectangle, just in the center of the screen. Let's see how this could work, or this could look like in let's look at step two. The only like really interesting part here is, and I will just really superficially run over the changes, but there's not, don't worry if not everything like falls into place right away, is that in our model struct, added points, which is a vector of two-dimensional vectors. So like two-dimensional vector is something with x and y coordinates, for example, so like a position in space. And so I just like collect all these points, and they will later make up the points that define the rectangle. And then just in the, I started with just here in the model function. So like, okay, if I need like a list of points that define my my rectangle, I can start with an empty vector, generate a couple of points, push them into the vector, and that's it. Maybe to note here is that I push point number one twice in there, because the function that I use to draw the stuff is called is a polyline, which is technically only a line. So I have to like put in the beginning point twice, so it actually closes the entire thing. But that's just like to note here. And the way that I kind of like distribute the points and the rectangle to get a rectangle is that I like use a random function. So in this case, random float 32. So like I get something between 0.0 and 1.0, and then multiply this by the maximum width and height restrictions that I want my rectangle to have. So let's say maximum like width and height of like 100 in this case. So I get like something in between, and then I use like negative values on the individual corners to kind of like push them out, so that I don't get like, how would you say it? Just like a random lump of points that doesn't like, may have like four corners in a way, but is not really rectangly shaped. And with this, I can like kind of like pull this a little bit out, so I get something that is more or like resembles more like a rectangle that you would imagine if you just think of like, oh yeah, a rectangle. With that, and then let's quickly look at like how we actually draw the thing. I removed the part that draws the ellipse, or like the circle that we saw, and actually draw a polyline, give it a color, and give it a weight, which is the width, or the stroke width of the lines that we're drawing, and then I give it all the points that we just created. These are like in our model points vector that I have to clone, because points wants to take ownership here. So if you run this and like maybe like code it at some point and you're like, why doesn't points like I get a compiler error? Maybe clone this because some of the functions actually want to take ownership, and in the view we can't. We only have like an immutable reference to our model. Okay. With that being said, so I'm quickly gonna like quickly running this again. So we now have like one random rectangle, even though this also looks kind of like a triangle because smaller sides, but that's okay. From here on, we can like move on to step 3, which is drawing a grid of these random rectangles. This is already kind of like stylish in its own way, kind of like pop artsy. Let's see how we can do that. Look into the next step, this step 3. I'll define like a couple of like magic numbers that I need for the grid and everything else on the top. But in this step, what is kind of like the biggest part is that I kind of like started to abstract introduce more abstract concepts of like the way that I want to organize the code. So maybe I pull this up again to better explain. So I thought that I want to have a structure that I call square structure, because that's kind of like the name of the art piece, and that each structure represents one position in the grid, and that later holds the color, and then also all the individual rectangles that are drawn on this position. So in the end, we will have like a vector of square structures that represent the grid, where each structure sits on one position, has a color, and then also all the rectangles that are drawn on that position. But first things first, in the first step, I just want to have the position, which is again like a 2-dimensional vector, and then the points that we previously had, except that previously we just had one points vector just directly on the model, and now it just like push it into this, or like reassign it to the square structures struct. Okay, then just impl square structures. This is the same points code that generates like a random rectangle, and then I calculate the position based on the position in the grid with a little bit of nudging in the coordinate system to kind of center it. Let's go here. Write a little function that is just 2 nested for loops because it's simple and it just works over the ranges that I want my grid to have. I think I said in this case it's 7 by 9. Generate a new structure, push these structures into a vector, and then we can have this vector of square structures in our model. So here's where I call it, here's where I put it into my model. And then in the view, we basically iterate over the structures in our model and draw this polyline. We now have this new X and Y where we actually have to like specify the position, but the rest pretty much stays the same. Cool. On to the next step, where I randomly put color here because I wanted to now get away from just as like the original purple and steel blue, I think they're called, or plum and steel blue, to like more into the direction of the colors that Vera used in her sketch. So this is going to be the next step that we try, just like per each structure also have a color. This is pretty straightforward. I actually also added the rand crate, so I get like a nice API for like choosing a random thing from a vector. Also pull in a nannou color, and then on the square structure struct, I can say, hey, we will now also like have a color, and the entire magic, or the biggest part of this, is like this rando color function that just defines this like predefined vector of color. So I want to have like actually like a lot of say in these are the only colors that I want to use. But this could also be like a cool entrance point for saying like playing actually with the color composition in the piece, of saying like, hey, maybe instead of RGB we want to like use HSL, and then play with like maybe the saturation levels or the hue anything like that. So this could be like a nice place, but I chose to keep it simple here, just have predefined colors, and then choose a random color from there, and then assign it to the struct. And then when we draw it, I just, like previously we only had steel blue, and then say, hey, now each structure has its own color, please draw this. Boom. And this was it for color, and we're almost there, because in the next step, where things go a little bit crazier, is where per each structure, we now not only draw one rectangle, we draw multiple. But with everything like we already have like put in place, this is actually quite simple for us to achieve. Okay, let's see. Or is it simple? Let's find out. I defined another value up here, which is just like the maximum number of rectangles I want to like, or like squares that I want to draw per structure in the grid. And I also decided to add another layer of maybe abstraction, if you want. Added a new struct that I just called square, which is just now holding the points for each square. So like I'm basically just pushing around this the initial idea of how do I draw a random rectangle, and now it lives just inside square, and square structure gets in turn a collection of squares. So the square structure has a position in the grid and a collection of squares that are like drawn on top of each other, and they all share the same color. Cool. Which then in turn, so maybe one more step is that now when we generate, or like when we create a new square structure, I also say like, hey, for each structure, fill this vector with a new square. And then when we draw it, it's just another nested for loop for drawing. And this is it. And that was actually not that much code to like get to this visual effect now, because in the end it was fairly simple. If we think about it. Whoop. So with step 5, we're kind of like there-ish, I would say. So we could play with like some of like the magic numbers that I defined at the top to like maybe widen or constrain like the rectangles a little bit more, maybe the number of iterations. But I actually wanted to have some sort of interactivity, because there's a couple of things that I definitely want to play with when I saw this first, which is for one, changing the color, so like the color assignments of the different structures, but then also the number of rectangles that are drawn per structure. And I thought like, okay, I kind of want to maybe play with 3 aspects of the thing, and I have a 3-button mouse, so let's like put some of like the events on mouse interaction so we can play with it a little bit, which is going to be the last step that we look at. So first, it looks kind of like the same, but when I click with my left mouse, I basically regenerate all the squares that are drawn, but the colors stay the same. But with the right button click, I can like assign the colors or reassign the colors, but the positions stay the same. And when I scroll, I can reduce or increase the number of the rectangles that are actually drawn, or like the squares that are actually drawn per structure. So like if I go all the way down to 1, I can we're kind of like stepping back to the initial step that we had, but then I can also like decide on like how many lines I actually want to have, and like then choose something that I think looks kind of good. Maybe something like this, maybe a little more. So let's see how we can do this, because actually events are handled really nicely in nannou. I'm a big fan. Let's see where we go. Let's go here in our model function, where the nannou window itself is created, and here we can register the events that we want to look out for. I chose mouse released, so like when the mouse button is click but release out, and mouse wheel, which is when you scroll. And then these just get like the functions that should be called when these events happen. So let's look at mouse released, which is this one. And the interesting argument that we get here is button, which is of type mouse button, which we can match on. So we have mouse button left and mouse button left and mouse button right. And then I can just say, I also have access to my model here. We get a mutable reference to our model here, so I can like also update my state. So I can say, so for left mouse click, I iterate over my structures, and I also defined a function that I'm not explicitly going to look at here, but just basically regenerate all the points in all of the structures, so like the squares actually. And on the right button click, I also iterate over it, but call something that is called set color, which just picks another random color from the predefined vector. And then I don't even have to touch the rest, because the rest just trickles down into the visual representation. The other part is here, mouse wheel, where the interesting argument is dt or delta, kind of like the difference in like the mouse position or the mouse scrolling. But we can also match on mouse scroll delta line delta, which is a tuple of like x and y. So like, because in theory you could scroll horizontally and vertically, but I'm only interested in the vertical scroll. So I'm only like on the only like the structure for y here. And the other funny thing is that y is either a negative 1.0 or a positive 1.0, depending on whether you scroll up or down. So I have a little guard here to tell me actually in which direction are we now scrolling. Then I have a little bit of a setting boundaries, because I actually don't want it to go out of hand. So like a maximum number of 10 is what I defined, and at least 1, otherwise the sketch breaks. And then I count up and down another. This is just like a little property on the model that globally defines how many squares I want to draw. And then as for the drawing itself, I can like make use of a nice or like more of like the functional features of Rust, because in the iteration loop where the actual squares are drawn, I can simply say like take and then this global number of squares that exist, and just draw this amount and don't really care about the rest. And I thought that was really cool. For the sake of time, I don't want to like get into some of the other, like I feel like in this part it's really like cool, like the things that Rust gives us for like handling stuff like this, like especially pattern matching and some of the functional things are so nice to work with in Rust. And if I think about like some of the stuff that I did in processing or in P5, where it's like kind of like always a little bit more complex, I feel like working with this in nannou is like really a smooth experience. So that was really cool. And that was a whirlwind tour of how to get something like Vera Molnar's square structures thing, but like implemented in nannou, just to give you a little bit of an insight into how you could like plan out a way, like a little journey on where to go and like maybe what to think of. And then in the end, it's really small incremental steps that get you there. And with this, I want to like already like kind of like go into like a little wrap up, because there's so much to talk about and so much to learn. So I prepared a resources slide. I actually have 2 resources slides. One is just like Rust and nannou specifically. There's a nannou guide, which is probably like also like a very good way to like get familiar with some of the concepts behind nannou, especially like about the coordinate system and how like drawing works. But then there's also like another generative art tutorial that is pretty new, where you recreate gravel or shutter, which is another like a piece that you maybe have seen. It's also like one of like the first things that you learn when you like a lot of tutorials take this on as like a first project for generative art. So there's a tutorial for that. And I also want to highlight a session by Alexis Andre, who did all the sketches that are on the nannou website. So all the cool animated stuff is Alexis Andre's work. And he gave a session at GitHub Universe about nannou and creative coding in Rust. And this is like also like it's 30 minutes. It's very, very cool. And also like gives you a really good insight into like how he thinks. I think I really enjoyed it. And then more links, but I'm not going to talk about all of them. There's another resources slide with just more generative art things. So you have like, if you planned on sleeping tonight, maybe don't sleep and read through all this stuff, because it's at least as interesting as sleeping. And with that, I'm actually at the end. Thank you for listening to me. Yeah, and that is it. And then we can do questions, I guess.
Awesome. Thank you very much, Lisa. It was an awesome presentation, and I can't put it any better than Carl did on Discord. He wrote, "I'm really inspired, and now I have something to do for my vacation next week." Really amazing. So yes, absolutely. It was a very good presentation. Thank you very much. We have some questions. In fact, let me show you the first one. This one. Now, Rengare, I'm not sure if I pronounced the name correctly, asks, is the image responsive? That is, if you expand or shrink, I guess he means the window, will the rectangle change size?
So the way that I code, so good question. The window itself, you can just like resize freely. The way that I coded it right now, it's not responsive, but you do get, for example, the way that I registered the mouse events, there's also an event called it's either resize or window resize, where you can actually like then get the chance to update the like all of the measurements in your sketch based on what happens in this resize. So you can, the way I coded it, it's not, but there's definitely tools to make it.
Okay, thank you very much. The next question comes from Stefan. He asked whether nannou would have some APIs to also generate video or image files, or maybe even have APIs for sound.
Also very good question. So the video parts are still, let's say, in development. There is a feature to like save images as like basically screenshot your sketch, so like save what you have as a file. That exists. The video stuff is it's still like a very young framework. It's definitely in there, like the entire like range of video, and then also video manipulation and all the stuff that comes with video. I'm not great with video, so I didn't actually look like too much into it. And now I forgot the second part of the question.
It was about sound.
It was about sound. Sound is really interesting. So there's already like APIs for the OSC, open sound control thing. So if like there's no synth. Oh, now I have to think. I think there's no synthesizer or like anything that actually synthesizes sound in nannou. But if you want to like have your nannou sketch interact with external things like MIDI controllers or anything else that speaks OSC, this is already possible.
Interesting. Yeah. Next question we have from Harald. He asks whether you know which graphics APIs or crates are used by nannou in the background.
That's a good question. I'm not like a super graphics crack, but the nannou tries to like use the most like advanced or like state of the art kind of like APIs. So they're working very hard on the like Vulkan and what's the new thing called Web GPU. So like basically all like the new super exciting yay. We try to squeeze as much performance out of our graphics cards as possible. Also preparing stuff for like WebAssembly. So like everything is pulled into it. They're working hard on this. They're also contributing to like the Web GPU crate. Again, I'm not like super duper into the graphic stuff, but it should be fairly cutting edge, I would say.
Okay, thank you very much. The next question, I'm not 100% sure if I fully understand it. The question was the backend of Blender 3D technique. Shall we call it as generative art? Can you interpret this question?
So there is. So my interpretation of this question is: you can do. Can you do creative coding with Blender? Mm-hmm. Yes, you can. All of like the like Blender has like so many like functionality around like generating various like visual effects for like 3D stuff. So if you're talking about that, and if you're playing around with that and then like generate beautiful like 3D imagery or like 3D models, this is definitely creative coding, because this is also like the next step would be then like for me is like to then 3D print this stuff, or there's like so many things that where people like actually have to like generate like models that I then like, it could be jewelry, could be installation pieces, anything. So is Blender a creative coding tool? Definitely.
Okay, interesting. I would like to ask a question too. Maybe you have listened to the community news that we did at the beginning, so then you know that we do a lot of work with kids. And when we work with kids and teach them the first steps in textual programming, we mainly rely on P5. We love P5, and the kids love P5 because we build simple games with them.
Yeah.
Is nannou a platform for building a simple game, like a classic arcade game or something like this?
You can probably. I actually have not made a game in nannou yet, which I probably should do. There's definitely like if you can make a game with P5, like nannou has the same kind, like the basic textual things. You can build this with nannou, like a snake game or Tetris or something, or Breakout. Like is Breakout the standard game that like just a little 2D, like I walk around, collect things.
Yeah.
Absolutely.
Nowadays, all the things that you mentioned, we already built it. So we built Snake, we built Breakout, we built the obvious Dino Run and things like that. So yeah, we will definitely check it out. Maybe that will be an interesting extension to what we do at Coder Dojo. Lisa,
maybe one more addition. So nannou doesn't feature WebAssembly yet, but it will come up. So like ultimately in a couple of months you will be able to like write it and then also have it run in the browser, and then I don't know, I also really like P5, but like maybe you don't need P5 anymore.
Yeah. Okay. I will definitely give it that. Thank you very much. Lisa, I would like to close with one important information that I would like to first give you or ask you. Have you ever been in Linz before?
No.
Do you know that Linz hosts the Ars Electronica Festival, which is one of the largest electronic arts festivals in the world, with hundreds, if not thousands of artists over the years? It started already in 1979. And while you were talking, I was, of course, Googling. Vera Molnar was, in fact, at the first Ars Electronica Festival in 1979.
Of course, I know Ars Electronica, but I did not actually make the Linz connection. That is fascinating.
So maybe we will find a possibility for a Rust Linz meetup at the time when the Ars Electronica Festival will be there, and then you can visit this city, take a look at Ars Electronica, and do another talk here at the Rust.
I would love to.
Awesome. That would be awesome. Thank you very much. Thank you for being here, and thank you for this great talk. Are you on our Discord server?
Not yet. I was too nervous to do that, but I will do it now while I listen.
Yeah, if you want, that would be awesome. Maybe some people have questions. If you like, you are always very welcome there. So, thank you, Lisa.
Thank you.
Have a nice evening.